In the next slide, you will see a problem. A cuboidal wooden cricket stump stand has measurements given in the figure: 20 centimeter length, 10 centimeter breadth, and 6 centimeter height. The base of the stump is in conical shape, having a depth of 4 centimeter with 3 centimeter diameter. The wooden block is hollowed out to hold the cricket stumps. Find the surface area of remaining wooden block. Find the volume of remaining wooden block. To approach this problem, we have to find the surface area of cuboid first. That is 2 into LB plus BH plus LH. That gives us 760 centimeters squared before the wooden block is drilled to hold the stumps. Now, base of cricket stumps, there are 3 circles that is drilled out. That is 3 pi r squared. That area is to be removed from the wooden block. That is pi r squared is equal to base area of cones, that is 22 by 7 into 1.5 into 1.5. That gives us 21.195 centimeter square. So this is roughly 21.20 centimeters squared of base area of cones have been removed. And then there are 3 conical depths to hold cricket stumps. This is curved surface area of cone within the wooden block. That is, if you run the finger, you will come to know that it is the curved surface area of the cone. Inside, there are 3 depths to hold 3 cricket stumps. So this is given by the formula pi RL. So you have to add this area pi RL to the remaining wooden block. Therefore, the total surface area of the wooden block is the total surface area of cuboid 760 centimeter plus 3 into pi RL, curved surface area of 3 cones, that is 60.33 centimeter squared, minus the base area of 3 cones, 21.20 centimeters. Surface area is 799.13 centimeters squared. The surface area of any object refers to the external surface area, including its internal surface area. Volume refers to the material or liquid contained within the object. The volume of remaining wooden block is cuboid volume minus volume of conical end of the stumps. So cuboid volume is 1200 centimeter cube. 20 multiplied by 10 multiplied by 6 gives 1200 centimeter cube. Volume of conical end of stumps, there are 3 stumps. 1 by 3 pi r squared h multiplied by 3 cones gives us 28.26 centimeter cube. So volume of cuboid is 1200 centimeter minus volume of conical base of stumps removed, 28.26 centimeter cube. Then the remaining volume is 1171.74 cm cube. The next problem is about the gulab jamun cylindrical container. It has a height of 50 centimeter with base diameter 20 centimeter and is filled with 75% sugar syrup of its volume. 500 gulab jamun pieces in each of 6 centimeter long, cylindrical width 3 centimeter diameter, shaped like a capsule with hemispherical ends, are dropped into the container. Each jamun absorbs 30% of sugar syrup of its volume. How much syrup will be absorbed by 500 jamuns? What will be the remaining sugar syrup? Optimally, how many jamuns can be made in multiples of 100 with the syrup available? Now we have to draw a picture of cylindrical container with base diameter being 20 centimeter, height being 50 centimeter. The volume of sugar syrup contained in it is 75% of the volume of the cylinder. Now the cylinder volume is pi r squared h into 75%. That gives us the sugar syrup contained in the cylinder is 11,775 centimeter cube. Now the jamun is of 6 centimeter length and the cylindrical portion is 3 centimeter long. and two hemispherical ends, that is having a radius of 1.5 centimeter. So volume of such jamun is pi r squared h plus 2 by 3 pi r cubed multiplied by 2 for two hemispherical ends. Therefore, pi r squared h plus 4 by 3 pi r cubed gives us pi r squared into h plus 4 by 3 r. On simplification, you get that 35.33 centimeter cube. That is the volume of each jamun contained in the container. Now each jamun absorbs 30% of its volume sugar syrup. That is 35.33 into 30% is 10.6 centimeter cube. So each jamun absorbs 10.6 centimeter cube of sugar syrup. So 500 jamuns can absorb 500 multiplied by 10.6 is equal to 5300 centimeter cube of sugar syrup. So the remaining sugar syrup in the container is sugar syrup originally contained in the cylinder is 11775 centimeter cube. 500 jamun absorbed syrup 5300. So remaining sugar syrup shall be 6475 centimeter cube. How to use the sugar syrup optimally? Total sugar syrup contained in the container is 11,775 centimeter cube. Each jamun requires 10.6 centimeter cube of sugar syrup. So dividing 11,775 by 10.6 gives us 1110.85 jamuns. Therefore, roughly about 1100 jamuns can be made with this syrup. A decorative block is made of two solids, a cube and a hemisphere. The base is a cube mounted by a hemisphere. The diameter of the hemisphere is 4.9 cm. Find the total surface area. Total surface area of cube is equal to 6 into side squared. So 6 into 7 cm into 7 cm side is equal to 49 cm squared into 6, which is equal to 294 centimeters squared. Surface area of the hemisphere on top minus base area of hemisphere is 2 pi r squared minus pi r squared. That is pi r squared. So surface area of hemisphere on top, we need to add this pi r squared to the surface area of cube. Pi r squared 22 by 7 multiplied by 4.9 by 2 multiplied by 4.9 by 2 gives us 18.86 centimeters squared. So adding this area to the cube surface area, we get total surface area is 312.86 centimeters squared. Now in the next problem, a solid sphere of radius 6 centimeter is melted and recast into a hollow cylinder with external radius of the base being 5 centimeter with height 32 centimeter. Find its internal radius. The volume of solid sphere melted is 4 by 3 pi r cube, that is radius being 6, 4 by 3 pi into 6 cube, that is 288 pi. Volume of hollow cylinder should be equal to this volume of sphere. So volume of hollow cylinder is equal to pi into big radius r squared minus small radius r squared into h. That gives us pi into 25 minus r squared into 32, which must be equated to 288 pi. So this gives us r squared is equal to 16. So r is 4 centimeter. Therefore, the internal radius is 4 centimeter.